Welcome to aminacademy.com. In physics, let us discuss about potential. In physics, a potential may refer to scalar potential or the vector potential. In either cases, it is a field defined in space from which many important physical properties may be derived. Leading examples are gravitational potential and electric potential, from which the motion of gravitating or electrically charged bodies may be obtained. Here, potential may be referred to as scalar or vector quantity. In this case, the field defined in space, from which many important physical properties may be derived. Here, further, the potential difference between the point A and B is the work done against electrical forces in carrying a unit positive test charge from A to B. That means potential difference between 2 points we will define now. That is, the potential difference between a point A and B is the work done against electrical forces in carrying a unit positive charge from A to B. Next one, the potential difference between 2 points here. Look at here, this that is VB minus VA. Potential difference between the point B and from the initial point A. This is VB minus A is potential difference. Here, suppose this circuit battery is connected. Here we have to measure voltage, that is potential difference between them is we have to connect like you have to measure. If you measure the ampere current between these two places, you have to connect ammeter in series. A potential difference between any 2 points in the electric field is defined as the amount of work done in moving a unit positive charge without acceleration from one point to another along any path between the 2 points. This is a definition of potential difference. It is denoted by dV. dV is dW into dQ. Or the potential difference between the point A and B is defined as the shift in the potential energy of a charge Q divided by the charge shifted from A to B. In SI units, of electrostatic potential difference is volt. The unit of potential difference is volt. Potential difference is said to be 1 volt if 1 joule of work is done in moving a charge of 1 coulomb from one point to another in an electric field. This is a different definition of volt. A potential difference is said to be 1 volt if 1 joule of work is done in moving a charge of 1 coulomb from one point to another point. If positive charge is moved from a point at a higher potential to a point at a lower potential, energy is liberated. Next, we'll discuss about absolute potential. The absolute potential is represented as the amount of work required to bring an object to its current position from the point of infinite distances. From infinite distances to the current position, we need work to bring a unit charge. The potential difference is the electrical potential difference between 2 points. Electrical potential between 2 points, that is V equal to W by Q. Then further you can say V equal to K Q over R. The absolute potential at a point is the work done against electric forces in carrying a unit positive test charge from infinite to that point. Hence, the absolute potential at a point B is the difference in potential difference from A to infinity to the point B. We know that V equals W by Q, work by charge. Then here K value 8.99 into 10 raised to 9 Newton meter square by Coulomb square. In general, we can say V equal K into sigma Q1 by Ri, Qi by Ri. Now, electric potential energy PE. Now we will define electric potential. To carry the electric potential energy is a potential energy measured in joules that results from conservative Coulomb forces and is associated with the configuration of a particular set of point charges within a defined system. An object may be said to have electric potential energy by virtue of its own electric charge or its relative position to their electrically charged objects. Look at here. Here, electrical potential energy is equal K into Q1 Q2 over R, where K is approximately 9 into 10 power 9 Newton meter square per c square, Coulomb square. Now, electrical potential energy further we will discuss. To carry a charge Q from infinite to point where the absolute potential is V, work in the amount of QV must be done on the charge. This work appears an electrical potential energy stored in the charge. Similarly, when a charge Q is carried through a potential difference V, work in the amount QV must be done on the charge. This work results in a change QV in the potential energy of the charge. For the potential rise, V will be positive and that is potential energy will increase if Q is positive. But for a potential drop, V will be negative and potential difference of the charge will decrease if Q is positive. Next one, we'll discuss about relation between voltage and potential. Electric potential energy exists if there is a charged object at the location. Electric potential difference, also known as voltage, is the external work needed to bring a charge from one location to another location in an electric field. We need electromotive force to push around the charges through the circuit against the resistance. Suppose that in a certain region, the electric field is uniform and is in the x direction, call its magnitude Ex. Between Ex is the force on a unit positive test charge, the work done in moving the test charge through a distance x, that is called B equal electric potential in x direction into distance x. Therefore, in generally, we can say B equal ED. D is electric potential, E is electric potential, and D is the distance between the two plates, between the 2 points distances. Next, electron volt energy unit. An electron volt EV is a unit of energy used in atomic, nuclear and high energy physics. It's defined as the amount of kinetic energy gained by a single electron when it accelerates through an electric potential difference of 1 volt in a vacuum. 1 electron volt is equal to 1.602176634 into 10 raised to minus 19 joules approximately. Suppose that in a certain region the electric field is uniform and is in the x direction, call its magnitude Ex, then we can say V equal to Exx and V equal to Ed. Then electron volt energy unit, the work done in carrying a charge, positive charge coulombs, through a potential rise of exactly 1 volt is defined to be 1 electron volt. Therefore, 1 electron volt, we can write 1 electron volt is equivalent to 1.602 approximate into 10 raised to minus 19 coulomb into 1 volt, which is equal 1.602 into 10 raised to minus 19 joules. Therefore, work or energy is defined here. Energy in 1 electron volt equal work in joule over charge of 1 electron. So far we discussed basic things in potentials. That is, we discussed about potential difference between 2 points and absolute potential, electric potential energy, relation between voltage and potentials, electron volt energy unit. We have done. Please subscribe our YouTube channel.